Welcome to Excel 2013 Statistical Analysis video number 41. Hey, if you want to download this workbook and follow along, click on the link below the video. Hey, we're on the sheet Accounting Data, and we want to answer a number of probability questions using the NORM.DIST function. This is the normal standard curve that we've been talking about over the last few videos. And here is some data. Different accounting jobs, different cities, different mean annual salaries, and the standard deviation for each mean. And so we want to ask the question, hey, if we are trying to find a job between 50 and 60,000 in Seattle, in USA in general, and in Oakland, California, what's the probability that we could find a job in any one of these places between $50,000 and $60,000? So we're going to start by building a formula down here. Notice we can use the NORM.DIST. We know the mean, the standard deviation, and the lower and the upper. Now here's a chart just for the Seattle data. And as we talked about earlier, when you're doing between probability, we're going to take the area all the way from the low end all the way up to the biggest x. And then we're going to subtract all the way down here to the second x, that area. Subtract those two areas, and we'll have our answer. Equals NORM.DIST. Our x, we got to take the bigger x first, comma, the mean. There's the mean for Seattle. Relative cell reference, right? Comma, standard deviation for Seattle. Relative cell reference. Comma, cumulative 1. Now, if I enter this, this tells me the probability of getting a job in Seattle, 60,000 or less. It's all the area from the very small all the way up to that 60K, F2. But now I need to subtract NORM.DIST. And the second x will be the lower x, comma, the mean for Seattle, comma, the standard deviation for Seattle, comma, 1, close parentheses. All of those are relative cell references. So when I Control Enter, I get number formatting as facade. That is pulling that number formatting there. That's a currency with no decimal showing. I'm going to go up to Home. I can see up here in the number group, I select General, or I can use the keyboard Control-Shift, grave accents, or tilde to apply the general number formatting. That's the probability in Seattle of getting a job between 50 and 60,000. If I copy this over, go to the last cell and hit F2 just to make sure all the cell references are correct. 67% chance in Seattle, 16% in the USA. Remember, that's a pretty broad swath of accounting jobs, and 56% in Oakland. Now we want to go over to our next question, the gas data sheet. Now here we have some data about Seattle gas prices and Burien gas prices. And we want to ask the question, what is the probability of finding a gallon of gas in Seattle that is between $2.10 and $2.30? Well, we have a lower and an upper x. So we simply enter our x values, $2.10, enter, and $2.30. Now, if we're going to use the NORM.DIST functions and the normal probability distribution to solve this problem, we have to assume that gas prices are normally distributed, and in general, they are. So we're going to use that model. Equals NORM.DIST. Oh, yeah, we just did this. We take the upper, comma, and the mean is our Seattle. Our standard deviation is for Seattle, comma, and cumulative. That gives me everything $2.30 or less. So there's a 36% chance that I would find something for $2.30 or less. F2 minus, and we'll do our NORM.DIST, our lower x, and then our mean for Seattle, our standard deviation for Seattle, and comma 1 for cumulative. Enter. So the probability that we could find a price between $2.10 and $2.30 is about 30%. Our next question, what is the probability of finding a gallon of gas in Burien that is more than $2.50? Well, we can see $2.50. That's going to be bigger than our mean, and it's on the upper end. So what's true, our function, if we give it $2.50, if we just did straight NORM.DIST, it would calculate everything from the low end up to that $2.50. But I want everything on the upper end, so I equals 1 minus. And now I can do NORM.DIST. Everything up to 250, that's the x, comma, the mean, Burien, comma, the standard deviation for Burien, comma, 1 for cumulative, and close parentheses, Control Enter. So we have about a 28% chance of finding a gas price in Burien of $2.50 or more. Hey, that's the probability for 250. But what about $2.59? Instantly, we get an updated probability. The probability of getting 259 or above in Burien, hey, about 15%. All right, let's go over to our next example, Ketchup Filling Machine. Now, ketchup bottle lists on the label that it has 20 ounces. Past historical data for the manufacturing facility shows that the machine fills with a standard deviation of 0.2 ounces. What lower and upper value would we expect for 2.5 standard deviation range? What probability is associated with those upper and lower values? Well, we can certainly calculate the x lower and upper given a number of standard deviations. So for the lower equals, hey, give me the mean minus the standard deviation times 2.5, and enter. So it looks like on the lower end, we'd have 19.5 ounces equals the mean plus standard deviation times 2.5 standard deviations, and enter. So 20.5 on the upper end. And that makes sense. 0.2 plus 0.2 plus half of 0.2 is 0.5. Now the probability, we have our upper and lower equals NORM.DIST. There's our upper, the mean, the standard deviation, 1 for cumulative, close parentheses. That's the upper, so I subtract norm, and I need the lower, comma, the mean, the standard deviation, comma, 1, close parentheses, Control Enter. The probability that a bottle could be between 19.5 and 20.5 ounces is 98.75%. Now, if we didn't have to calculate the lower and the upper as part of our question here, we could have simply the probability of getting minus 2.5 standard deviations, and x has to be greater than or equal to and less than or equal to positive 2.5 standard deviations. Well, the probability of that could have used NORM.S.DIST. That just needs the z. So on the upper end is our 2.5, comma, 1 for cumulative, minus NORM.S, and then minus 2.5. comma, 1, close parentheses. And when I enter, I get exactly the same thing. I'm going to highlight these two cells, right-click Format Painter, and boop. All right, so in this video, we answered a number of probability questions using NORM.DIST, and even one using NORM.S.DIST. Here we had our ketchup example. We did a question for gas data in Seattle and Burien, and we even did a question that involved accounting salaries in Seattle, Oakland, and the United States. All right, next video, we'll talk about the exponential continuous probability distribution. All right, see you next video.